This is about recycling persistence volume. Now we'll talk about dynamic provisioning. I think only a couple of slides left, so bear with me for 2-3 minutes, then we'll close this chapter, volumes. So what is dynamic provisioning? So far what we have discussed is that administrators create the persistence volumes, and the application developers use persistence claim to claim those. And if the claim has all exist, this a persistence volume is already existed by the existing persistence blue claims, and you create a new claim, and you don't have the storage available in persistence volumes, you will not get it. So how do you solve this? Dynamic provisioning. So what this does is Kubernetes can automatically provision persistence volume without admins doing it. And that's where, remember, in the storage class, we left it blank, and I said we'll discuss it later. So we'll see we use storage class for this, and we'll see how it works. So admins can deploy provisioner and define one or more storage class objects. So to let users choose what type of persistence volume they want. They just need to assign a name to the storage class using particular provisioner. So they can have a storage class for NFS, they can have another storage class for AWS EBS. If your company is on 2 clouds, which is very rare, but let's assume it's on 2 clouds, AWS and Google. So they can, and they are on-prem also. So they can create one storage class for NFS, one storage class for AWS EBS, one storage class for, GC file system. So, and then those are the things which administrator will create. Then as a user, as an application developer, I just give the storage class. Then automatically dynamic provisioning keep happening. So when storage class is using claim, the provisioner will automatically create a persistence volume. It needs not be created by the administrator anymore. So Kubernetes has provisioners for most of the vendors. On-premise systems might need admins to develop a custom provisioner. It has for NFS, but if you have something, very specific, some specific type system, then you can, the administrator, and you are on-premise, you are not on cloud, then the, Kubernetes administrator have to develop their own custom provisioner. You can see what provisioner you have using, your storage class you have using this Kubernetes get storage SC storage class. So let's see this kubectl get storage class on my local. This is a storage class we have. This is a provisioner I have, and so this I can use in my persistence with claim. Let's see this. All the storage classes available here. So you can see the various storage. AWS you have. So this is a storage class, right? For AWS, Elastic Blob Storage, GCPD, Cluster File System, NFS, vSphere. There are Azure Disk, Azure File. For local, you have these many storage classes available, and you can see this, right? Storage class resource. You can. This is how it's created with the definition of AWS EBS storage class. This is how it's created, correct? And it has all the recamp policy, volume expansion, you allow true, whatever, right? So you can go through this. If you want to have something of your own, and you can click on the links of this to go into more details or something, right? This is what we have seen so far. If whatever you are using is not there in the list here, then you can create your own custom provisioners. So Kubernetes allows you to do that. Okay, moving on. So you can create a, so you have this is what we just saw, right? You can have this create your own custom storage. You have this YAML which uses the storage class, and the storage class is based upon this EBS, and like GP3 in EBS you can have standard, GP2, GP3 standard can be only, EBS standard can be only till 1 terabyte, GP2 I think it can be till 100 terabytes, GP3 I don't remember exactly GP3, but I think it has more IO, faster IO or something like this. And of course this reclaim policy and everything is same. You can have this persistence view, and here I'm using storage class name as standard. This is a meta name standard I have given here in the storage class, and the persistence claim I'm using the standard, and so it will work. Okay. This is the last slide. You can directly use the cloud. You don't have to use for example persistence will you can directly attach the EBS volume yourself also if you want, right? So let's see how that works. So you have this, you can create the volume yourself here, and then you can have a pod which uses the EBS, and this is the, this is the image you are using for, just I think it's for Google, AWS is EBS configuration, and you are mounting this here, so you can do all of that yourself also. You can have this Azure disk, Azure disk, Azure file. So, so idea is that, if you want to use, see here, if you see, I'm not using any persistence volume claim or anything. I'm just directly using this, file systems myself. This is the, this is a Cinder volume. I don't know what that is, but if you want to use that directly, you can always use that directly also if you want. And you saw example of init container. So if you want to, like for GitHub repo, if you want to attach, you can use init container. One thing you can explore is that in init container, can you mount EBS also? Right? This is what I'm trying to figure out internally also. We use EBS extensively. So we are creating a POC. We are using init container. If you can attach EBS volume ourselves, I'll let you know what we find. But this could be one option. So persistence volume claim is one option. Init container is another option. You can directly use this, file system using this yourself outside your claims and everything. So these are the few ways you can use the volumes. Let's go back. I think that's it. So that's about the volume.